So I wanted to create a video where I walk through a couple of fairly straightforward trigonometric equations similar to stuff that you're going to see in the homework. In this video I'm going to identify solutions specifically in the interval from 0 to 2 pi, as opposed to finding all solutions, which I might have in a different video. So to start out, in general, your mission is to isolate the trig function, so in this case the cotangent theta. And so we could do that by subtracting the square root of 3 from both sides of this equation. This little writing tablet that I'm using is just not, there we go. So now we have cotangent theta equals negative square root of 3. Once you have the trig function isolated, now you'd want to move over to the unit circle to start to identify solutions. We also want to keep in mind, so cotangent is the reciprocal of tangent, and tangent is equal to the ratio y over x. So cotangent is equal to the ratio x over y. So when we're looking for solutions on the unit circle, we want to be thinking about the ratio x over y. So for example, at pi over 6 radians, if we do x over y, you'd have the square root of 3 over 2 over 1/2, and let me write this down. So here you'd have square root of 3 over 2 over 1/2. If you, sorry, that keeps happening. Let's say you bring the fraction up out of the denominator. Instead of dividing 1/2, we could multiply by the reciprocal. The 2's are going to cancel, and we end up with square root of 3. I'm doing this just as an example of how we can think about the values of cotangent looking at the unit circle. So the thing to know here, the way these 2's cancel, that's going to happen every time these are both over 2. So when you're thinking about the ratio x over y, if they have the same denominator, you can go ahead and assume, so those are going to cancel out, and my ratio is square root of 3 over 1. So same deal here, cotangent of pi over 4 would be square root of 2 over square root of 2. These denominators are going to cancel, and so that's equal to 1. Okay, we're looking for negative square root of 3. So I'm going to move out of quadrant 1. If we do x over y over here in quadrant 2, now we're going to get a negative. So x over y at 2 pi over 3 right here would be negative 1 over the square root of 3. And then negative 1 here. And then at 5 pi over 6, cotangent of 5 pi over 6 will be negative square root of 3 over 1, because the 2's are going to cancel the same way they did over here. So here we will get that negative square root of 3. So one solution between 0 and 2 pi radians is 5 pi over 6. Now we should consider the whole interval from 0 to 2 pi, so we should keep working our way around here. In quadrant 3, x and y are both negative, so if we take the ratio x over y, it's going to be a negative over a negative, so it'll end up being positive. So I'm going to go ahead and skip quadrant 3 and move over here to quadrant 4. Now if I do x over y, I get a ratio negative square root of 3 here at 11 pi over 6, because the ratio x over y will equal square root of 3 over negative 1, so negative square root of 3. So 11 pi over 6 is another solution. And that's the 2 solutions to this trigonometric equation. Now for the second one there. Square root of 3 times secant theta plus 2 equals 0. So I'm going to start out with the same principle. I want to isolate the trig function. So I'm going to move the 2 over, subtract both sides by subtract 2 from both sides, and then divide by the square root of 3 to get rid of this. Divide by the square root of 3. So secant theta equals negative 2 over the square root of 3. Now, for me, I would switch this to the reciprocal function. So if secant theta is equal to negative square root of 3, or negative 2 over the square root of 3, then the reciprocal, which is cosine theta, would equal square root of 3 over negative 2. Or I'm going to write that as negative square root of 3 over 2. So I'm using the reciprocal identity there. So now I'd move over to the unit circle. I'm looking for when is cosine, which is given by the x coordinate on the unit circle, equal to negative square root of 3 over 2. And I'll use the highlighter for this one. So x coordinate negative square root of 3 over 2. That happens here at 5 pi over 6, and it happens here at 7 pi over 6. And those are the only two places that cosine is equal to negative square root of 3 over 2 in the interval from 0 to 2 pi. So our solutions here are theta equals 5 pi over 6, or theta equals 7 pi over 6.